Well, Lab 1 Charged Tape, and this is by Caitlin Schmidt. Okay, so for the introduction, this lab aims to examine the interactions of charged pieces of tape and to calculate the amount of excess charge. Materials used were clear tape, a ruler, a flat surface, and some support objects. The model we used is a computational model in GlowScript to show the forces acting on the tape. And the key results were the charge on each piece of tape and the number of electrons each piece of tape lost. So now for the key principles of this experiment. So the first one that is needed is Newton's second law, which is right there, and it's the change in momentum is directly proportional to the net force applied over time. We also need Coulomb's law, which is also there, and that is the force of attraction or repulsion between two electric charges. And we also need gravitational force, which is also put there, and that is the attractive force between any two objects with mass m. So here is the observed model that we created, and I have an example diagram right there. And basically the system is the tape that is attached to those gray supports right there. And the surroundings is the charged tape, which is tape A, being held by the hands, and everything else in the world. And the distance between these tapes A and B is 0.025 meters. Part 1 of the calculations for this experiment, and this is where I found the charge of tape and the number of excess electrons, and those other calculations on the right side are measured ones, or ones that we already knew or were given. And right here is just my calculations that I did to prove. Is the second part of my calculations where I calculated the surface area of the tape and also the number of atoms that are present. So there are my proof of calculations right there, my notebook pages. Here is the initial conditions of the computational model in GlowScript, and it's just setting up the code so it has all of the calculations and everything. Here is the calculation part of the GlowScript model, where it calculates the force of gravity, vector force, and then also calculates the charge and the distance between the tapes to eventually calculate the electric fields of the tapes. Here is the actual visual result that came from the GlowScript model, and basically the charge on the piece of tape is that, and it also gives you the number of electrons lost and the number of atoms for every electron lost on one piece of the tape, and the electric field at tape B due to tape A, and the electric force on tape B, which is very cool. Assumptions are that the air resistance and friction are considered negligible. The long tape is treated as a point charge, and each piece of tape is assumed to have the same amount of evenly distributed charge, and the errors are that there may be an unequal distribution of charges on each tape, and the charges can be lost due to handling or environmental factors. Electrons had positive charge and protons had negative charge. What would change about the observations you made? So the outcomes in this lab would still be the same. The charged pieces of tape would now carry a negative charge, and they would continue to repel each other while attracting to the now positive charged objects. Why? Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? So the tape begins to neutralize when touched by hands or other objects as they attempt to recover the electrons lost. So basically, that is not good because you want the tape to continue to be charged. Thank you for your time, and I hope you have a great day.